All right, so we're going to begin our calculus unit now, something everyone's been waiting for, right? No more vectors. And so what is calculus? Calculus started with two problems. So here you have this curve. One of the problems was how can you accurately find the slope of a tangent on that curve? And two, how can we find the area under that curve? So these aren't nice areas. It's not like we have a triangle and I say find the area under that, right? Or a linear function. That's easy. But if you had a curve, how do you find that area? And a slope, that's pretty hard too. Not a secant, right? We're not connecting 2 points. That's easy. But a slope at a point is hard. And so two physicists slash mathematicians, Isaac Newton and Gottfried Leibniz, independently showed at about the same time how to actually do this with new functions that we are going to learn about. One's called differentiation, which is finding the slope of the tangent. And this is called integration, which is finding the area under the curve. Now, in our first chapter, we're going to sort of lead up to differentiation, but we won't actually start it until chapter 2. And then most of the course will be differentiation. If there's time at the end, I'll take one lesson and sort of introduce integration so you know what it is. But for today, and you'll find in our first unit, which is going to be all on limits, I'll explain what those are in a later lesson, but there's a very important mathematical skill that you've all learned before that we should go over today, because we're going to be using a lot in analyzing different limits in our first chapter. And that is how to rationalize denominators. So let's say you have an expression like this. 3 over 4 root 5. Okay, that root 5 is not a rational number. So remember, a rational number is can be an integer, or pretty much any fraction would work. Right? But root 5 doesn't work. So that is what we call a radical. So what we want to do is remove the radical from the denominator, because it's a lot easier to divide a number by an integer than to divide a number by a radical. So what we do is we're going to multiply numerator and denominator by that square root. Root 5 has to be the same on both top and bottom, so that essentially you're just multiplying by 1, because that ratio is 1. If you multiply any expression by 1, you don't change anything. So when we do that, on the numerator, we just get 3 root 5. And then on the denominator, root 5 times root 5 is, well, root 5 squared, which is just 5. So we're left with 4 times 5, which is 20. So this is the exact same expression as this, but you can see we've essentially moved the square root to the numerator. Now, if you have a case like this one, where you have terms in the denominator, what you can do in this case is multiply it, top and bottom, by the conjugate. So the conjugate, in this case, root x plus root y, will have a conjugate, root x minus root y. You just take the opposite sign. And when you do that, the point is so that in the denominator, you see you have a difference of squares. So root x plus root y multiplied by root x minus root y. So that simplifies just to being x minus y, if you remember your difference of squares. And usually when you did difference of squares, it wasn't root x plus root y. It was probably x plus y. I can write this. Probably x plus y and x minus y. Okay? And that would just equal x squared minus y squared. But in this case, with the root, all we're doing is putting a root there, a root there, a root there, a root there, and therefore you'll have a root here and one here. And so the root of x squared just becomes x, and the root of y squared just becomes y. So same idea. And then on the numerator, you have that 5 times that conjugate that we have. But you have removed the square root in the denominator, which is what our goal was. All right, so going over some examples. In this case, it says simplify the following by rationalizing the denominator. Okay, so here's what we're going to do. We're going to multiply top and bottom, so numerator and denominator, by that conjugate, which would be root 6 minus root 3, all divided by the same thing, right? Root 6 minus root 3 has to be the same. So on the numerator, we just get 2 times root 6 minus root 3. And on the denominator, you've got your difference of squares, so you have 6 minus 3. All right, that's it. All we'll do is just simplify a little bit there. Can't really simplify the numerator. But the denominator we can certainly simplify. There you go. Done. Not so bad. Let's try the second one. Second one, same thing. We're going to multiply numerator and denominator by that conjugate. So here we have 2 root 6 plus 3. So I'm going to multiply by 2 root 6 minus 3. Top and bottom. So in the numerator we have 5 times 2 root 6 minus 3. Denominator, we have our difference of squares, so that would be 4 times 6, right? Because the 2 is not in a square root, right? So if we square that term, it's 4 times 6, and minus, again, this is not in a square root, the 3, so it's minus 9. 4 times 6 is 24, minus 9 is 15. So we can simplify that a little bit further. Okay. So that could be 1 and 3. There we go. We're left with 2 root 6 minus 3 all over 3. Okay, so now our last example is an interesting one. This we don't do very often. But as you'll see later in this chapter, it can sometimes be very useful. All right, so we're going to do the same thing though. I'm going to take this and I'm going to multiply numerator and denominator by the conjugate of the numerator. So root 7 minus 3 is going to be root 7 plus 3. All over root 7 plus 3. Remember, top and bottom has to be the same, so you're only multiplying by 1. Otherwise, you're changing your expression. All right, so now our difference of squares is in the numerator, so we're going to get 7 minus 3. And in the denominator is where we have this 2 times root 7 plus 3. So in the numerator we get 4 over 2 all times root 7 plus 3. And again, this can be simplified, right? Because we have 4 over 2. So that can be the same as 2 over 1. Okay? And I lost my square root at some point everywhere. Don't know why. It should have been there this whole time. There we go. So now we have 2 over root 7 plus root 3.